How's it going, guys? My name is Shadil Ferris, and I will be starting a little series on Calculus 3. Should also include here Calculus 4 and Statistics. And the course codes for these will be Math 2ZZ3 and Stats 3Y03 or 3J04. So, I don't want to take too long for an introduction, but there are three important things I would like to address before we get started. I'm very straight to the point. I have my external set of notes that I'll be using as reference. I do not claim now or ever will to be a professional in what I'm doing, and I am genuinely just taking questions from my assignments, putting them on here to help other students either in the same scenario to understand, to help me understand it more, and to really make sure I know what I'm talking about. And with that, for this class, I believe we do have a formula sheet. I will double check that quickly, but for the most part, I am quite certain that we do. Give me 1 second. So as of yet, we don't have a formula sheet, but I believe it will come up in following lectures. So, in stats, we definitely will have a formula sheet, and we'll Calc 4 to be determined. As of now, the biggest focus you'll see in the coming videos will be Calc 3 and statistics. Secondly, my handwriting. I would love for people to watch and love my handwriting. I understand that probably won't always happen, and so I will always leave the opportunity to let my viewers explore people whose handwriting is better than mine. With that being said, if you guys have any recommendations on my speed, or even if I should slow it down and focus on my handwriting a little bit more, I will try my best to do so, but no guarantees. Third of all, and most importantly, I would say, is process. And so my old high school teacher was huge on process, and so I will try to explain exactly what I'm doing and describe the way I approach these problems. So, some background knowledge to follow along would be integrals, partial derivatives, I came back from a stats class and it's 12 o'clock in the morning. Partial equations and partial equations, I can't even say that word right now. That's how you know we're really messed up. But I'm sure when I record these videos in the morning or listen back to them, I will realize how stupid I sound, and you guys will see how stupid I can be in the next who knows how long. It's really differential equations. Holy shit. Yeah, differential equations. There we go. So let's describe differential equations really quickly. So a differential equation, unlike a regular equation, such as, let's start off with a nice color here. Let's go with this. Okay, awesome. So, differential equation, use as DE for right now, is an equation which solutions are functions. Now, I'm using this with what I know and I'm simplifying it a shit ton. But that's basically it. You'll know you have a differential equation when you see y prime not y prime is not the sole value in that equation. So y prime, for example, plus y equals 0. So you have rate of change and you have the actual function in that. Now, the solution to, let's get rid of that dot. A solution to one of these equations is a function or functions, multiple families of functions, in which you can get into different branches. Orthogonal is one that you'll see come up quite often in Calc 2, the predecessor to Calc 3. So, in differential equations, you have many different forms, normal form and differential form. And differential form, we use this fancy schmancy notation for, and you don't really have to familiarize yourself with this. Basically, important thing to know is this is I at x, this is p at x, and this is q at x. Okay? And there's equations that involve it. 3 of them, which will be used a lot in Calc 2. The reason why I'm going through with this is to understand and give kind of a preface to some of the stuff we'll be doing later on. I won't go super into detail on theory. That's what university is for. And so I'm really just here for application, helping you guys out. So I at x we call the integrating factor. Okay. And this equals e to the integral of p at x dx. You then have p at x, which is usually what's in front of y. So if I'm going to give it to you like this, you'll see this form come up something like y prime plus 2y equals 1. So you could see where, and I'll just use the pointer for this, you could see where q at x comes in, where p at x comes in, and that p at x is going to the 2, not the y, just the 2. And if there's a negative here, then it also goes to the p at x. And the integrating factor, which is right here, you're solving for. Now, your p at x is just the coefficient out in front. Next equation you'll use quite a bit is I at x times p at x. The derivative of that. Awesome. And then this will equal q at x. Oh, why is that font so small? Let's go back here. This will equal q. Oh my god. It goes right here. Why did it get so smaller all of a sudden, all of them? Okay. Q at x times p at x. Okay. And you'll end up taking the integral of both sides just to get this out. And you'll basically be solving for y at this point. I'm sorry. I believe, just for the sake of correctness, that this is just y. Okay. Or p at x times y. Honestly, I'm not too certain, but you don't really need to care about that too much. So, when that comes up further on, we'll make sure and crunch out the details. Now, since it's 12 o'clock, and I don't have a huge amount of time, what I'm going to do is I'm going to get to the stuff that I really need to know. Because most likely what I really need to know is what you really need to know. Okay? So, I'm going to throw out a couple buzzwords just so you guys could search these up later, because I really don't have the time or mood to do with them right now. So, differential form, normal form, maximum interval of definition, intermediate, initial value problem, implicit solutions, initial value problem. And now we got to what I need, which is problem 4. Alright, so what I'm going to do is I'm going to send this to myself and open up my Teams. Go to the chat. Can I copy this? No, I can't. Okay. So we're gonna copy this from there, go back here, and can I just paste it? Allow paste. Amazing. Okay. So what we got here is we have this differential equation and we want a unique solution. Okay. And so I'm going to try this question the way I think it should be done. X squared plus y squared equals 25. So I'm pretty sure this question is an implicit solution. I'm gonna check my teams to double check like what exactly this is. Because I tried solving it before, as you can see, I got one wrong. But yeah, let's just figure it out. MVPs after. Population grows. Initial value problem. All right. Okay. So that was really the last slide of this one. Okay. Singular solution. So we have this differential equation, and we have a condition. All right. Now we have multiple different points that we need to make sure meet that condition. All right. Okay, so that's definitely not it. I'm looking for a question that revolves around a unique solution through the given point. And I did some work on it earlier. That's why I thought I had 3. And let me give you some background onto why I think I had 3. So I put y in there, and you get y squared, 100 minus y, you get 0. That all turns out to y prime equals 0. So basically, you have y prime equals 0. Now, that means that if we take, for example, this graph right here, all right, it doesn't want to correct, but that's fine. And then we take the slope of the tangent. Let me get that in a different color so it's visible. Take the slope of the tangent across 0, right? So, slope of this tangent, or better yet, let me get this example perfecto. All right, so I guess something like this. This is a line. Could be y equals 2x. All right, or better yet, I don't know why I keep saying better yet. Oh my god. Let's just do like this. This is my first video, guys, so you're gonna have to give me a little bit of a break. Okay, so let's just say this is 1, all right? So you have fuck it. Okay, let's make that line horizontal so it actually makes sense. Okay, so you have y equals 1. Derivative of this equals 0. I'm basically just trying to tell you derivative of a line is 0. It took me some time to tell you that. All Okay, let's keep going to find a question that looks at least a little bit like this. Holy fuck. I'm tired. I feel like definitely when I get caught up on this and I'm not tired, this will flow a lot smoother. So, um, we have, and let's just make sure we write down what we got here. So we got y prime equals e to the x squared times, let's just put it like this, y squared plus 100, or no, this was minus 100, that's not gonna make sense, minus 100 to the 1/2, which is just square root. Okay, awesome. Now, what we could do is expand it in there. So, this is not a linear differential equation. And the reason why I know it's not a linear differential equation is because of this guy right there. So you'll see what's going to happen right now. I'm going to have y prime equals, I'm just going to try some shit, e to the x times y. So I'm multiplying it in, right? I just realized you can't really do that. It doesn't really help you. Unless I square the prime term, but there's no point in doing that. So this is a waste of time. So what I was gonna do is basically move this guy into the bracket by just getting rid of that square. And then I still have this square at the top. So I need to square both sides. So square both sides of the equation to get rid of this. But then I have dy over dx squared, which I can do nothing with. I move in no direction. That's why I just stopped doing it. So a unique solution. I just need to understand what the hell they mean by fully unique solution. We're definitely skipping some points in my lecture notes. So so we can give the trivial solution of y is neighborhood of 0. Okay, so I'm guessing this is what you gotta do. So you gotta find some value such that when you, let me put it in actual. So you gotta find some value that when you put in y into here, you'll get it to be 0. So we know y equals 10. Okay. And then another thing that I have a cushion written down, which is the partial derivative with respect to x over the partial derivative with respect to y in the neighborhood. So we're going to try and understand this together, of 0. Okay. So since f doesn't depend on x, okay. And then he just interval of solution / existence doesn't have to be the max interval. So we need the derivative to be continuous, which I remember being important. Be continuous. Okay, cool. So let's just take the derivative of let's just take the derivative of this. Cool? So, if you guys want me to move the screen out, just let me know. Y prime equals e to the x squared times y squared minus 100 to the 1 over 2. Okay. So y double prime, or d2y by dx squared. I don't like to write it like that. Too much shit to write, so we're just gonna go back. Awesome. So first thing we look at, we got two variables, ex squared, and like two components is what I like to say. Okay, so we're gonna take the derivative of the first. I know it's product rule, and honestly, if you're taking your class at this point, you should be pretty familiar with this. So derivative of the first, think of this like e to the box. Don't worry about the dot. E to the box, and derivative of any e to the box is e to the box times ln e times the box prime. Okay, so when you have e to the 2x, the derivative of this equals e to the 2x times 2 times ln e. It's because you're taking the derivative with respect to x. Cool. So we understand that concept. Now let's go back and do this question. I could probably do the scribble thing, but I don't mind typing it. So e to the x squared times the derivative of that, which would be 2x times ln e. We know that's 1. And then the first times the second, which is y squared minus 100 to the power of 1 over 2. Awesome. First term done. Now let's go to the second one. Chain rule. 1 over 2 times y squared minus 100 to the 1 over 2. Now remember, we are taking this derivative with respect. Oh shit. We're taking this derivative with respect to y. Fuck my life. Okay. Let's go back. I had a feeling I was going too fast. Okay. My apologies. So, if we're taking this with respect to y, this e to the x squared is a constant. So really, we just have 1 over 2 times y squared minus 100 to the power of negative 1 over 2 times the inside, which is 2y. Awesome. So in total, we have e to the x squared times 2y. Let's make that a nice straight line. Over 2 times y squared minus 100 to the 1 over 2. Okay. Awesome. Now, is this continuous? Always. Absolutely not. Whenever y equals 10, we got problems. Okay. Great. So what I think we could start doing now is, because we have that, right? Let's just check the other 2 points and see what we get. So I is negative 4, 9. Okay. And if we check the original equation, or y prime, we'll get e to the 16, because it's negative 4 squared, okay, times root 81 minus 100. Okay. Now, I don't like this because we have negative 19. So we got an imaginary number. And you'll notice also in the second one, we will also get an imaginary number. So I don't think that this has any unique solutions to the given point. I don't think they exist. They exist, but we don't deal with imaginary numbers in this class. At least from what I've heard. So maybe we just try this one. We have e to the 4 times 64 minus 100, which is also bad because we have negative 36. Okay. All right. So, I'm going to go with H, and H is correct. So, none of them. H. All right. Let's go on to the second question. And now, I'm not going to give you guys the solutions to the second question because I don't want to copy and paste how many different grams. Yeah, I don't want to copy paste like 8 different graphs into my notebook. But I will tell you exactly what we are doing. So, if this thing could be any slower. All right. Let's copy this. Yes. Okay. All right, everything good here? Great. Okay. Which of the following is a direction field for this equation? dy by dx equals xy minus 1. So let's go to our related lecture notes. Let's see. Okay. So, for this, what we kind of got in my lecture notes is we will be studying qualitative behavior about the solutions without having the solutions. So, for dy by dx, which is first order, equals y prime, any x naught, y naught gives you the tangent and all the values graphed as the directional field of dE. So that makes sense, right? If you have, and I'm just going to explain this for the sake of explaining it. If you have f at xy, right? So you have f prime at x, you could say, or y prime. Just know that this is the rate of change. And we know that if we have like some graph that looks like this, okay, and we take the rate of change at that point, we are taking the slope of the tangent. So the tangent line to that graph, okay, singular point in time. Now, if you do that for a regular graph, that's what you get. And if you do that for an implicit differential equation, or just call it differential equation for right now, you're taking the tangent line, or the rate of change, with respect to many multitudes, many families of graphs. So each slope of the tangent, right, is like a line, like a point in time that represents that graph. And you need graphing software to do that. So it's a directional field because it's a shit ton of slope of tangents. And these slope of the tangents all are actual functions. And so you're graphing just a bunch of functions. Now, if we take, and I also have this written down, if we take dy by dx equals xy, okay, and let's just tack in this nice coefficient out in front, and we say, okay, I want y prime at x naught, so we get 0, 2, x naught, y naught. Awesome. This is now the slope of the tangent at x naught. Agreed? Because that's exactly what the function is. And so, similarly, when we take, so the slope of tangent m is defined as y final minus y initial over x final minus x initial. Learned this a long time ago, guys. This also gives us the slope of the tangent. And so we're really trying to find a relationship between these two. Okay, so how does this help solve our problem? Okay, so basically what we got here is excluding this -1 for right now, right? We have an equation which for any 2 points will give me this basically. Like if we just don't worry about this for right now, we have exactly this. Okay, so x times y, you're literally just talking about a graph that looks something like this. Maybe a little bit downwards. Like, you should probably make it like this. I don't want to make it too high up, but like, okay, that looks like it's just passing through the damn thing. Let's just go like right here. Okay, so call this 0.2 x naught y naught. Now we have x naught y naught minus 1. So does my rate of change become larger or smaller as a result of it? And now remember something. What happens if any of my x values equals 0? And what happens if any of my y values equals 0? This will be very important. Because for any of these, okay, my rate of change will equal -1. Okay. So this means that I'm basically rise over run. So I'm going something like this. My vector is going to look something like that. And if I'm on the x-axis, then my vector will look something like, it'll be the same shit. But yeah, I'm gonna look at my graphs really quickly, and there's definitely some weird things going on. I don't want to say A has got some weird, like, funky shit going on. You got some vectors going up, you got them going down, and like, and I'll try and represent it in a way that makes sense. You also have some vectors going up and more vectors going down. So you could see how this is kind of like sectored off. That's the best way I could describe this, the way this graph looks. Looks really weird, and I don't think, quite frankly, that's it. Now, I want to say that, like, you know, if I have x equals 2, y equals 2, this reminds me of my favorite graph, which goes whoop, just like that. Because for any x equals 2, you'll have like, so actually go a bit higher than that. Shit blows up. So you have 2, this will be 4, 3, you'll have 9. And then I'm going -1, so it's like, you know, I'm still up there, but now I'm definitely a little bit further down. So I'm not going as high up anymore. Now for any 2 negative numbers, I should have, any 2 negative numbers, I should have it going up the graph. Oh, yeah. So I really shouldn't have any negative slope here. A lot of them should be going up. So I think if I have a negative and a positive x, so negative x, positive y, it should be going down. So let's think about it like this. I think this might be the easiest way to try and help visualize and answer this question. So let's go like that. Okay. Positive x, positive y. Positive x, negative y. Negative x, negative y. Negative x, positive y. Cool beans? So, this is really the way it's gonna, we can try and imagine this. Okay, so this quadrant will produce, frankly, only negative slopes from what I can imagine. This one will produce solely positive. This one should produce positive as well. And this one will produce negative. Okay? So, I really like F. And you guys might be wondering why. Let me see. It's just so hard to see these damn lines. Negative. No, these ones shouldn't be climbing up. Nor these ones. Nor those ones. And there shouldn't be like a line just like that. We're taking like the general direction of the graph, right? So when I said x equals 0, you'll have a rate of change of -1. So when x, any one of those ones where x equals 0, I'll have -1. So the rate of change should be decreasing anywhere along the x-axis. I think it's E, to be honest. I'm an absolute legend. Holy shit. Let me show you guys what I just did. I got that right first try, by the way. So this was the other. I'm not gonna copy and paste it, but like this was the graph. Actually, it might be like useful for you guys to have me write over it. Okay. So this was the answer. I can go down. This is what I was talking about. So you're gonna have positive values. Let me write this in a color that doesn't blend in with the thing. You're gonna have positive values down here, negative values down here, positive values over here, and negative values over here. And it ties back to what I was saying, which is like you have this positive x-axis and you also have a positive y-axis. And, you know, we said 0, it should always be decreasing. Anywhere along 0, along x, it should always be decreasing. So that's why you see that general trend downward. Negative x, negative y, positive. Okay, and the closer it gets to 0, the more negative it should start to become. And you guys can get the rest. Awesome. Let's go to the next question. All right. So, once again, we have y prime equals x squared minus y minus 1. All right. So, if this was squared, it'd make life a lot easier, but fuck me, I guess. Huh. You know what I want to do here? So we got y equals mx plus b. I just don't like the idea that I'd be subtracting my rate of change, right? Because like the last one, it was part of it. I was thinking of like maybe I could rearrange this to be y equals x squared minus y prime minus y, right? And this would always be m equals delta y over delta x, right? So let's just do the same shit. Honestly, it worked last time. All right. So let's take this original equation, this one right here, and see what we can come up with. So, all right. For the most part, in quadrant, and I'll list them for you guys. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. For the most part, in this quadrant, you will have positive values. Why? You have an x squared. Subtracted from that is a y minus 1. This will grow exponentially faster than this one will. Okay? And this minus 1 is quite frankly insignificant. And that's how I got to that. So I'm really looking for the values. What sign will it be in that quadrant? Now, quadrant 2, where I have, and this is because I have a positive x and a positive y. Here I have negative x, positive y, negative y. So I have here a negative x and a positive y. Doesn't matter. It really doesn't. I should still have positive values here. Because that negative, it's squared, gone away, and the positive value will still affect it the same as it does here, and it'll be, frankly, insignificant with larger values. Now, here, this is important. Here, it'll also be positive. Okay? And I'm going to say, for the sake of it, this will also be positive. Why? Negative x value doesn't count, but now you also have an additional y value. If anything, these two down here where we have negative y, q3 and q4, should have larger slopes than q1 and q2, because simply the magnitude will be larger for the same exact values. Now, we said we're always increasing, okay? So anything that has decreasing in it, we'll just simply throw out the door. And I just need one of them. So these graphs, like I showed you guys before, they only go up to negative 3x, okay? So, negative 3, okay. For the most part, I want to go with the answer that just has increasing. Oh, what happens for 0? We didn't look at that. So for any x equals 0 and y equals 0, right? We have it equaling negative 1. So when I go closer, okay, so literally every quadrant should be increasing, but anytime, okay, so it's D. All right, that was easier. Oh fuck, it's not D. Okay. Why is it not D? Well, it's increasing everything other than when it gets close to the 0 axis, it's decreasing. Shit. Okay. I really expected it to be D. Did I submit D? Or did I submit... Yeah, I submitted D. I'm wrong. Alright. What was my last one? What was my last one? E? Okay. Alright, something's up here. So, any negative x values will produce much larger. Like if I take -2, I got 4 minus 2 minus 1. I get +1. Like I'm just barely increasing. Oh. Yeah, like even for that, I take +2, +2x, +2y. I'm getting 4 minus 2. Yeah, like I should still be increasing there. I don't see why for like those larger values we're decreasing. I could see why we'd start decreasing when we get close to 0. But other than that, you're losing me. You're losing your mind, bud. Huh. 1. That's huge. For any x equals 1. This is important. So for any x equals positive or -1, right? You'll have y prime equals 1 minus 1 minus 1. Doesn't take a genius to know it's this minus 1. So for any... Oh, gotcha. So I should really be looking at these graphs to see where that -1 is affecting it most. Amazing. Oh, and then I also have to, okay. So this is positive or minus 1 with a positive y value. Okay, so this will equal -1. But then for x equals 1 plus 1 minus 1, I get a positive value. So basically, to reiterate what we've done so far, for 1, okay, -1 and 1, right? For the positive y values, and that positive is happening when I'm subtracting a -1. So in Q3 and Q4, okay, between 1, like anything else should be positive. And as a matter of fact, everything between -1 and 1, okay, in Q3 and Q4 should be positive. Now, even after that, when I go to x equals 2, right, and like y equals 1, we know we're going to get a positive number there, guaranteed. Now, for Q1 and Q2, okay, for -1 to 1, okay, I'm going to have a negative slope. And for x equals 0 or y equals 0, okay, I'm going to have a negative slope. So let's go back and look at that given this new information. So, it's not F. And if I look back at D, between 1, -1 and 1, you know, D still looks good. That's what's pissing me off. Oh, wait, no. Oh, no, Q, it should be increasing. Yeah, and then everywhere else it should be increasing. But like something's messing up here. I'm not quite sure what. Oh. let's see our options. So between -1 and 1, for Q3 and Q4, I should be positive. So for -1, so it's not A, because between 0 and 1 in A, with that negative Y value, holy shit. I keep overseeing these stupid fucking things. Because, like, if I have x equals 0.5, right? And I have that positive value. Oh, yeah, no, that'll still be negative. That'll still be negative. So, yeah. So, anywhere... Yeah, if I... 0.5 negative... Oh, fuck. Because if I have 0.5 squared, right, with a positive, let's just say like +1, right? So I have -1, which was +1, -1. Okay, so equals, so 0.5 squared, 0.25, I don't even know if that's 1,000% correct right now. That's the least I could do, though. So at least check, make sure that's right for you guys. I want to tell you guys I'm so tired. I'm like so unbelievably tired. Long day today. But part of life. So yeah, we're right on that. 0.25. Okay. -2 equals -1.75. So really at this positive this point right here, we also have a negative, which is what we said. So I don't know what the heck I'm talking about. Now if I put that -1 in there, so 0.5 squared +1 -1. Yeah, we have that positive 0.25. Okay, great. So yeah, so if between Q3 and Q4 in A, between 0 and 1, you have a negative slope, which is incorrect. Okay, and then let me get some better eyes on this because I can't see too well right now. So if we go to B, right, between 0 and 1 and Q3, Q4, we have a decreasing slope, which is also wrong. Same thing with C. Again, decreasing slope between Q3 and Q4, and from the interval -1 to 1. Now D is still what I think is right. I don't know why it's wrong. We have positive everywhere else, increasing between -1 and 1. But it's also increasing. It's also increasing like at 1. Like at 1 for Q1 and Q2. So that makes sense why it's wrong, but I've yet to find something that has given me better results. So between 0... Yeah, the DE is also wrong because I have a decreasing slope between 0 and -1, and the Y value is still negative at that point. So it's adding, and then it's subtracting 1. So it's like, for E, let me move the iPad a little bit. For E, right, I have Y prime equals, let's just say, I don't know, -1. Let's take a goofy number, -0.5 squared, and then I say, okay, so I'm subtracting -2, and then I'm also subtracting 1, right? It's the original equation. Okay. So at this value, I have 0.25 minus 1 plus 2. So you have 0.25 plus 1 equals 1.25. So it should also be an increasing slope between 0 and -1. So therefore E is wrong. F. I like the look of F because I have increasing between 0 and 1 and 0 and -1. And then I have the same thing that I was looking for where it's decreasing. The only thing is that around 0, at around 0 on the x-axis at the very least, when the x-axis is, sorry, when y equals 0, not when x equals 0. When x equals 0, let's write it again. So for Q1 and Q2, we already checked that Q3 and Q4 is correct for F. But for Q1 and Q2, when I have this x equals 0, I'm talking about just the y-axis, right? And so, yeah, I'm putting in any number, let's just say 2. So I have, and this is 0, so I have -2 minus 1. So I'm getting a negative slope of the tangent, which is fine. But now if I get to y equals 0, okay, so I just had like 4, which was -2 squared, minus 1 equals, oh, I'm fucking retarded, god damn it, right? Yeah, it's positive. So I think it's F because that fits what I'm looking for, the most at least. Yeah. Yeah. Yeah, F was correct. And let me share with you guys what F is. How long have I been recording for is the real question. Shit. Holy, I've been going for pretty much an hour here, or maybe 40 minutes, who knows. We'll just see how long my battery lasts for. So let's go to Teams. So I won't copy and paste. Actually, yeah, I said the same shit last time. Let's just do it. All right. So this is what I was talking about. And I'm just going to use the laser pen for this one. So between -1 and 1, we have this in Q3 and Q4. We have this increasing slope, as you can see, all the way up until here. Now then, after that point, what I was checking last was like along y equals 0, what's happening. And originally in Q1 and Q2, I thought it would just be decreasing consistently. But when I checked it right here and I set y equal to 0 and x to be any negative number, like -2, -1, I still got a positive slope. So that's why I was pretty confirmed about that. And then we also confirmed originally that between -1 and 1, that you would have a negative slope with a positive y in Q2 and Q3. So I was confident that was the right answer. All right, let's go on back to a word problem. And what I will do for ease of life is just copy paste both of them. Amazing. I really want to do this series with just like paper and pen. And tomorrow I'm going to go buy notebooks and look more into like, see if I can buy like a nicer camera. I got a pretty good camera right now, but it only records up to like 15 minutes. And this will most likely take a lot more than 15 minutes. All right. But yeah, so I'll keep you guys posted on that. I just like making videos in the meantime. So, consider the following autonomous first-order differential equation. And then blah, 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 blah. Critical points are y equals 2 and y equals -5, classify these critical points in the given order as asymptotically stable, unstable, or semi-stable. So I have the associated lecture notes that I took next to me. So let's go through that. So you need, for it to be autonomous, it must be for first order, which is perfect. We see this, we have dy by dx, and any coefficients that are functions next to y, that's why I say coefficients, should be pure x. But there is no functions of x next to y, so we're good on that part. And the only thing is that we have that squared there. It'll actually be cubed. So I'm a little bit worried about that. But yeah, I'm going to say, maybe my notes are misleading, but I'm going to say that even though that you'll get a y cubed here, I'm not so concerned. Actually, yeah, you'll get a y cubed. I'm not so concerned because the example I have it lined out in my notes is that I have a y squared. But as soon as you have an x times y, then you're getting rid of the autonomy of it. We state that a point where f at c equals 0 is a critical point. And so you're basically just looking at the function and seeing what values you could put in there to make it 0. And they give it to you. So they say y at 2 and y equals -5. So those are, yes, the critical points. Now, we're going to plot that. We're going to plot that on this line. This beautiful, beautiful, beautiful line. Let's go down here. So we have c equals 2 it was? Yeah, c equals 2. And we have c equals -5. And then up here we have positive infinity. And down here we have negative infinity. Amazing. So right here, you'd have some value like -6. Right here, you'd have some value like -4. Actually, it's pretty dumb on my end. I gotta switch these two around. Sorry about that. -5. So, sorry, to correct myself, you'd have a value like that. You could have a value like just 6 here. Okay? You could have that there, and you could have -7 here. Okay. And now we're basically just going, because we know it's 0. Tangent line is 0 there. We're just going to see if at these points between this and this, if it increases or decreases from 0. Okay. So let's write down the function right next to it. dy by dx equals negative y minus 2. And y, what was it? Plus 5 squared. Not going to expand it out. I don't need to. So, y equals 6. Alright? So, I'll have negative, positive, and then I will have a positive right here. So, I will have a negative tangent, which means here it's decreasing. Okay? Now, if I put 0 into this equation, okay, I'll do this in a different color. I'll have negative, awesome, positive, equals positive, increasing. I don't care what the number is. I'm just more so worried about the magnitude. And lastly, if I put in -7, negative, positive. So it's also increasing here. Amazing. Next page of notes. this one's not so useful for being completely fair. Okay, we're getting here. Unstable and asymptotically stable. Like, where did I write that shit down? I wrote down somewhere. Dude, I swear I wrote it down somewhere. It's all good. I'll just check the lecture slides. Alright, so let's see what we got here. Give me the money. Give me the money. Decreasing, critical point, blah, 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 blah. Where is my voice? Stable, unstable. Oh. Oh, okay. All right. So, yeah, so I drew my, so you gotta draw your face portrait, which is basically what I did here. And so what you'll tell here, what you can tell, so I said increasing, right? So where is it increasing? I went further away from it, or further down, so it increases the more I go there. Now, between these 2 points, I said increasing, so I put 0. So I went more towards here, okay, and it increases, which means the more I go down to here, the more it increases. The more I go up here, this I would say we'd call semi-stable, and decreasing. The further that I went to the top, I was decreasing, okay, which means there. If I'm 1,000% certain on that, which I'm pretty sure I am, but can never be too sure, right, guys? Okay. Yeah, that's good enough. Yeah, so I really just want to see, like, as I go towards infinity, am I increasing or decreasing? I'm decreasing, so going back down here. So let's check the thing. So y equals 2. Okay. Let's see what I got down right over here. Okay, so attractor is when 2 points go towards a certain point. So 2 is an attractor, which means it's asymptotically stable. Now, I'm going to say that when 2 of them go in the same direction, it's semi-stable, because like if this was going like down like this and towards it like that, I would say attractor. That's what's going down. That's what's going on right here, right? But it's also not doing something like this. This would be a repeller. It's more so just going in the same direction. It's going down, but it's going in the same direction. So I'm going to say semi-stable, because that's the only other scenario we have. So I'm going to lock in stable and semi-stable. So E. All right, that's correct. Awesome. Let's keep going. And last question that we got. God damn. It looks long. Alright. Let's take it piece by piece. Can I take a screenshot of this so I can move it down? Really hope so. Duplicate. Oh, okay. Nice. Don't fuck up my notes. Please, picture. I probably should use more of the page, so here I'll do this. Alright. For being honest, we only really... Oh, not that. We only need half of this. There we go. Alright. Last question. So, consider the following initial value problem. I don't even want to read the shit. I'm just going to go y prime equals y squared minus 15y plus 44 bracket bracket sine squared 2 pi y over 21, and we have y at 0 equals a. So a equals what? Such that solution is a non-constant function that satisfies the limit of our solution, y at x, as x approaches infinity equals 21 over 2. Alright. How the fuck did we do this? I also only got 12% left, so gotta get moving on this. I also gotta do some summarization. Looking for the lecture notes. Oh damn, this is a lot of stuff. Alright, there are questions before it, but like we won't go too much into those right now. So, when did this guy glue, like he glued a solution together? That's what I'm looking for. Okay, we're getting close. Alright, this is what I'm looking for. So, they want a solution for this, and there's two big conditions. Alright? So, for whatever function we choose, we need to make sure that the partial derivative is always continuous. Okay? And we also need to make sure that f function we choose as our original solution is always continuous. And I think that it is it. Okay, so what we gotta do is take the derivative of the function with respect to y, and yeah, so let's do it. So this is our fat function. All right, perfect. Alright, so let's take the derivative of this. Not so bad. What I'm going to do here to make my life easier is just write this out one more time, but with one minute detail. Sine 2 pi y over 21. This is squared. Just so it looks nicer. Now, taking the derivative, the partial derivative of the function with respect to y. So, 2y minus 15. Derivative of the first times the second plus the derivative of the second. So we had a couple things going on here. We got chain rule, and then we have another chain rule inside of it. So outer chain rule first, we have 2 times sine 2 pi y over 21 to the power of 1 times the derivative of what's on the inside. And now the derivative of what's on the inside would be cos 2 pi y over 21 times the derivative of what's on the inside of that, which y is considered just one thing, so 2 pi over 21. Okay? So this is our second term, and then we multiply it by our first term, which is 2y minus 15. Amazing. Okay. So now we have our second derivative. Okay, guys? And what we're going to do is simplify the shit out of it. Okay? So I'm going to go in. Just if you ever feel that you need me to slow down, just pause or slow me down. Alright, amazing. So, right off the bat, we'll have a 4. So we can't touch anything inside of these, of course. But we have this 4 pi over 21. We also have this 2y minus 15, which is just waiting to be factored out. And then we have the sine 2 pi y over 21 times cos 2 pi y over 21. God damn, it's hard to write there. But you guys, y, there's a y there. Okay. Additionally, we have this term. So what I can factor out here is a 2y minus 15. And I'm just factoring out, just for the sake of making it look easier to look at, sine 2 pi y over 21. What I get left over with is a sine 2 pi y over 21 plus 4 pi over 21, thank you for reminding me, Apple, times cos 2 pi y over 21. Okay, awesome. Where could I get some struggle here? Which is, I think, what kind of like my next step is. This is interesting. Why don't So the original one over here was x, y prime. And so we isolated for y prime. So I cannot take 0 or an interval. So I need something that's defined everywhere. Okay. I don't see why I can't just choose the same thing. I mean, it's not a bad option if we're being honest. So what I think I will do is, yeah, just straight up choose the same thing. Because, like, I mean, he just chose one thing. Okay, hold on a second. So in this case scenario, I'm being asked to solve for y at 0 equals x. Okay. So, this is hard. Let me look at the lecture notes. I don't really get it, to be honest. I don't get it, really. Oh, is it like the multiple lined ones? Where, like, I'm looking for, holy shit. I'm looking for where this equals 0. No? What the hell was the question asking me again? I'm looking, yeah, for where this equals 0. I'm just looking for that satisfied. But I'm not looking for just a graph. Okay, I think this is what I need. This is what I need. Oh, it's a hard ass question though. Alright. I feel like I'm hitting that limit, so I'm gonna go brush my teeth, go to sleep.